Okay, so welcome back to the deep dive. And wow, the sources you sent this time, they really take us deep, don't they? Right into the sort of technical guts of consensus protocols.
Yeah, it's pretty fascinating stuff. We're
Mhm.
looking at federated voting, which is the engine behind the Stellar Consensus Protocol, SCP.
Right, and then connecting that directly to how this massive mobile crypto project, the Pi Network, is trying to use it. It's quite the jump from theory to, well, millions of
It
phones.
really is.
So our mission today, basically, is to unpack federated voting, what it is, how it works, maybe where it's a bit shaky, and then see how Pi Network is actually grappling with this as they gear up for their mainnet.
hmm And it's worth saying up front, federated voting, or FV, it's a really clever piece of the SCP puzzle. It's how these distributed systems, nodes that don't necessarily trust each other, can still agree on things securely.
Okay, so agreement.
Right.
But it's not just a free-for-all, right? The sources lay out this structured two-phase process.
Exactly. Two core phases.
Hmm.
Keeps things orderly, ensures security.
Phase one is just called voting.
Simple as that. Yeah.
Huh.
Phase 1, voting. A node basically says, I vote for this assertion. Think of an assertion as maybe a block of transactions.
Okay.
But the crucial bit here is validity. The assertion can't contradict anything that node has already accepted in the past. That's rule number 1 for safety.
And there's another strict rule in this phase, isn't there? Something about changing votes.
Spot on. Once you vote in phase 1, you're locked in for that round. No changing your mind. You have to stick with your initial vote.
Okay. So you vote, you stick with it. What happens then?
Well, if a node sees enough of its peers, its trusted group, also voting for the same thing, it internally marks that assertion as accepted.
Accepted. So that's like a first step towards agreement.
It is. It gives the node a sort of provisional green light. That thinks,
Mhm.
okay, a decent chunk of the network seems to be leaning this way.
But provisional isn't quite enough when you're dealing with, say, money, right? You need something stronger.
Absolutely. Which brings us to phase 2, confirmation, sometimes called the vote to accept phase.
And this is where the real guarantees come in.
Yes, this phase is designed to provide much stronger guarantees. Not just about safety, meaning the transaction won't get reversed later, but also about something called liveness.
Liveness. Okay, let's pause on that. That sounds important. What exactly is liveness in this context?
It's fundamental. Liveness is basically the network's ability to keep making progress, to keep processing new transactions, to not just seize up.
So the opposite of being stuck.
Exactly. If a network loses liveness, it's effectively stalled,
Yeah.
frozen. And if this confirmation phase succeeds, the assertion gets the top status confirmed.
Got it. So if we're tracking a potential transaction block, it goes through stages.
Right. 3 main states.
It starts as unknown, just a proposal floating around.
Yep. Completely uncertain at first. Then, if it gets through phase 1 voting successfully,
It becomes accepted.
correct. And
Ah.
being accepted is already a significant milestone. The sources emphasize this. When your node accepts something, you have a guarantee that no intact node you know about will ever accept something that contradicts it.
Intact. That word again, it sounds technical, but feels important. What does intact actually mean here? Is it just online?
Oh, it's much more than just being online. Intact means undamaged, whole, behaving correctly according to the protocol. Not compromised, not buggy, not malicious.
So a well-behaved, trustworthy node.
Pretty much. The whole security model kind of rests on the idea that these intact nodes will play by the rules, especially that non-contradiction rule from phase 1.
Okay. And then after phase 2?
After successful confirmation, you reach the final state. Confirmed. That's the gold standard.
The point of no return.
Essentially, yes.
Yeah.
Once something is confirmed, your node can safely act on it, update the ledger, release the funds, whatever. The functional part of the network agrees.
All right, so federated voting sounds pretty robust, very focused on safety. But like most things, it probably has a weakness. The sources mentioned one, right? Linked to liveness.
Yes, exactly. Even clever protocols have potential pitfalls. And for FV, the Achilles heel is liveness. It's this risk of the stuck vote.
A stuck vote. So the system freezing up, like you said.
This is the classic problem for any system trying to reach agreement. It happens if the network can't achieve the necessary quorum.
Quorum, meaning like the minimum number of votes needed.
Precisely. Imagine too many nodes start voting for different conflicting things all at once. Maybe Group A votes for option 1, Group B votes for option 2, Group C for option 3.
And no single option gets enough votes to actually win.
Exactly. If no assertion gets that minimum threshold, that quorum, then the system just deadlocks. It gets
But
stuck. The votes might all be valid individually, but there's no consensus to move forward on any one of them.
and it can't fix itself.
Generally, no.
Not without some external intervention or maybe predefined timeout mechanisms. Transactions stop, the whole thing grinds to a halt. It really highlights how critical setting up those quorum configurations is for anyone running SCP.
Okay, that makes the transition to Pi Network really interesting
Yeah.
because you have this protocol, powerful but potentially prone to stalling if consensus isn't reached.
Right. And you're trying to implement it on a network built around, well, mobile phones.
Yeah, Pi Network is a fascinating case.
Yeah?
Started by Stanford PhDs back in 2019. Their whole angle is making crypto accessible, right? Letting people mine on their phones just by tapping a button daily.
Yeah.
They pitch it as simple, ecological.
And they're explicitly using SCP, using federated voting, as the basis for their mainnet consensus.
They are. The sources show they've been actively testing this. Their white paper apparently mentions 2 potential consensus variations they're considering.
But they have to pick one eventually.
Right, once they figure out the final distribution of their nodes. And the testing seems quite hands-on. They've had node owners submitting commands directly, like during that recent upgrade to protocol version 23. It shows they're trying to work through the practicalities of decentralized governance using this FV framework.
So this brings us back to that liveness issue. If FV needs a stable quorum, how does that work when your nodes are potentially millions of people just checking an app once a day? Doesn't that seem like a recipe for quorum problems,
Yeah.
for instability?
That is the central challenge for them, isn't it? SCP and FV were arguably designed with more, let's say, high availability stable nodes in mind, like servers in data centers.
Not necessarily someone's phone that might be off or have bad signal or the user just forgets for a day.
Exactly. Pi Network is translating a high commitment protocol into a potentially low commitment environment. The very thing that makes it easy to join, just tap a button, could undermine the stability needed for the consensus to consistently achieve quorum.
So if a whole bunch of users drop off temporarily,
Right, imagine a big power outage or a major mobile network issue in one region. If a significant chunk of nodes suddenly can't participate, can the remaining nodes still reliably form a quorum to confirm transactions? Or does the network seize up? That's the risk.
the network's fundamental stability sort of depends on the collective behavior of millions of casual users.
It really does. It means Pi has to work hard operationally to ensure their participating nodes are as intact and reliable as possible, even if they are mobile.
Which suddenly makes their sign-up rules seem less about bureaucracy and more about network health.
I think that's a fair way to put it.
Okay.
Look at the requirements. Download the app, fine. Use an invitation code, okay, that helps growth and gives a mining boost.
But the big one is using your real name.
Yes. And the follow-up, mandatory KYC, know your customer, after 30 mining sessions.
Why is tying it to real identity so critical for the federated voting mechanism?
Because it's their main lever against the unreliable node problem. It's how they try to ensure nodes are intact. If every participant is a verified real person, you drastically reduce the chances of malicious actors, bots, or people running multiple accounts just to cause trouble.
So verified users are more likely to be well-behaved nodes.
That's the assumption, or at least they are accountable. It increases the odds that the nodes participating in consensus are doing so honestly, following the protocol, which in turn makes it more likely that quorums can actually be formed reliably.
So KYC isn't just red tape. It's actually a core part of their strategy to make FV work in their context, to improve liveness odds.
It seems that way. It's like risk mitigation dressed up as user verification. Sure, there's a penalty if you don't register correctly, but the underlying goal seems to be fostering a more trustworthy, stable node population to avoid those dreaded stuck votes.
And they seem to be betting heavily that this will work, given the ecosystem they're trying to build around the Picoin.
Definitely. The sources mention things like the PiBazar, called the first community bazaar in Europe, places where people can actually spend Pi.
Yeah, I saw the categories listed. Cars, electronics, home goods, services, even alcohol and cigarettes, interestingly. A whole marketplace.
And that utility is key. If people can actually use Pi to buy and sell real things, they have a much stronger incentive to see the network remain live and functional.
Ah, so the ecosystem creates a reason for users to care about network stability.
It's a feedback loop, right? Utility encourages user commitment and participation, which helps stabilize the consensus mechanism by making quorum failures less likely. And a stable network makes the currency, and thus the utility, more valuable and reliable. It's quite clever if they can pull it off.
Okay, this has been really insightful. Let's try to synthesize this. We started with federated voting.
Right, the core of SCP's consensus. Great for safety, making sure transactions are consistently ordered across the network.
But with that inherent risk to liveness, the potential to get stuck if nodes can't agree, if quorum isn't met.
The deadlock problem.
And then we have Pi Network, taking this powerful but somewhat sensitive protocol and implementing it at massive scale on mobile devices.
Yeah, and using tools like mandatory KYC as a way to manage the intactness or reliability of their huge user base, trying to ensure those quorums can actually form.
So wrapping this up, what's the key takeaway or the lingering question for you for someone watching the space?
Well, if federated voting's biggest practical challenge is avoiding that stuck vote, avoiding deadlock due to lack of quorum,
Yeah.
and Pi's network relies on millions of global mobile users whose participation might be, less consistent than dedicated servers. The big question I'm left with is this. How resilient is their chosen setup to real-world shocks?
What kind of shocks?
Think big. A major geopolitical event, a widespread natural disaster, a coordinated cyber attack targeting mobile infrastructure, or even just that energy crisis scenario we touched on. If something knocks, say, 30% or 40% of their active mobile nodes offline suddenly,
Can the remaining network still function? Can it maintain liveness?
exactly, will the remaining nodes be enough and be coordinated enough to consistently reach quorum? Or will the network demonstrate the very fragility, the liveness failure that FV is susceptible to? The ultimate test might not be the code itself, but the collective reliability of its human participants under pressure. That's what I'll
Yeah.
be watching.